At 1:47 in the morning, somewhere over occupied Crimea, 3 drones are flying 50 meters above the ground at 160 kilometers an hour. They've been in the air for 31 minutes. Nobody on the ground has seen them yet. Ahead of them, a railway bridge that has survived this entire war without a single direct hit is carrying a Russian logistics train across it right now, at this exact moment, completely unaware that in less than 15 minutes, the ground underneath those wheels is going to stop existing. By the time this night is over, 8 drones will have flown into a defense network with exactly 13 minutes and 41 seconds to stop all of them. And that, as you're about to hear, was never going to be enough. To understand why one bridge matters this much, you have to understand what a bridge actually is in a war like this. It isn't a landmark, it's an artery. In occupied Crimea, every shell that reaches the front, every liter of fuel, every replacement soldier has to physically cross a small number of fixed points to get there. Roads help, but roads are slow and every truck on them is exposed and vulnerable in a different way. Rail is what actually moves real volume, hundreds of tons at a time on a schedule without needing a convoy of drivers exposed on open highways, which means a small handful of rail crossings are quietly doing the logistical work of an entire war effort. Take one of them down, even for a matter of days, and you don't just inconvenience a supply officer somewhere behind the lines. You start starving an entire stretch of the front of everything it needs to keep fighting. That's the real prize sitting at the center of tonight's story. Not a bridge, but the artery running underneath it. This didn't start at 1:47 a.m. It started weeks earlier with people who weren't even carrying weapons. Members of a Ukrainian resistance movement operating inside occupied territory had been quietly watching this crossing for weeks, from rotating positions along the rail line. They weren't counting missile calibers or identifying radar hardware. They were just watching the rhythm of the place, when trains ran, when the lights moved, when the guards changed. Piece by piece, that rhythm became a target package, and that target package landed on the desk of a Ukrainian special operations strike element known as Launch Cell Alpha, operating behind the southern front. Cell Alpha loaded 8 Firepoint FP-2 attack drones, a fixed-wing, propeller-driven, each one carrying a structural warhead somewhere between 105 and 200 kilograms. With a 6-meter wingspan and a cruising speed of 160 kilometers an hour, this was not some hobbyist quadcopter. This was a real aircraft, big enough that any radar with a clean line of sight would absolutely see it coming. Which is exactly why the entire plan depended on never giving that radar a clean line of sight. Flying at 50 meters, hugging the terrain for a 120-kilometer route, each drone had 45 minutes of exposure, guided by inertial navigation, GPS, and a terminal camera trained to lock onto the silhouette of a bridge structure the moment it came into view. 3 drones launched first. Call them the pressure group. Their entire purpose was never to destroy the bridge themselves. It was to fly straight at the defenses, get seen, get shot at, and force the system on the ground to burn through missiles and reaction time before the real threat ever arrived. It's a deliberately cynical tactic. Spend cheap, expendable airframes just to make the expensive defense system waste its limited ammunition on the wrong targets first. 25 to 35 seconds later, 5 more drones followed on a second bearing, fanning out south into the darkness, each one carrying enough explosive to actually do structural damage. 2 corridors, 8 drones. 1 fixed target that couldn't move, couldn't hide, and couldn't dodge. The first system to notice them was a Podlet K-1 low-altitude surveillance radar, a system built specifically to catch exactly this kind of threat, scanning a full 360 degrees from a 10-meter mast, sensitive enough to detect something as small as a tenth of a square meter on radar. An FP-2 with a 6-meter wingspan was well above that threshold. On paper, this radar should have picked the drones up from more than 100 kilometers away. But paper doesn't account for the curve of the Earth. At 50 meters of altitude, the radar horizon collapsed down to just 36.5 kilometers, which meant the crew got exactly 13 minutes and 41 seconds of warning, not more. Acquiring the tracks and handing them off to the next system in the chain ate up 2 to 3 more minutes. By the time the alert actually reached the ground-based defense battery, the window had shrunk to under 11 minutes. 20 kilometers out from the bridge, the drones crossed into a GPS dead zone deliberately corrupted by a Pol 21E jamming system covering the final approach. Most of the drones barely noticed. Their backup inertial systems and terminal cameras kept them locked on course. But one of the 3 pressure drones had been quietly accumulating navigational error the entire time it sat inside that jammed zone. Just half a degree of bearing drift, stretched out across 20 kilometers, adds up to about 9 meters of lateral error by the time you reach the target. 9 meters is more than enough to miss a bridge span that's only 10 meters wide. The jammer never crashed that drone, it just quietly moved its aim. Then the actual fight began. Guarding the crossing was a Panzer S-1 air defense system, 12 missiles loaded and ready, twin 30mm cannons standing by. This was not a weak system by any measure. 5 seconds after the first pressure drone showed up on the tracking scope, the crew locked on and fired a pair of missiles. 3 seconds of flight time later, while the drone was still holding its course straight for the bridge, the first missile found it and the drone came apart in the air. 1 kill. The second pressure drone was already inside engagement range. A second and a half after the last shot, the crew swung the system onto the new target and fired again. Another pair of missiles tracked out into the dark. Another kill, 2 for 2. The third drone, the one the jamming had quietly nudged off course, was already drifting wide of the bridge by this point. The crew tracked it anyway and fired 2 more missiles, but the drone had wandered too far off bearing, and both rounds missed. That's 6 missiles fired in 40 seconds. Half the entire ready load gone, and the real attack hadn't even arrived yet. 25 seconds later, the 5 structural drones showed up on a converging heading from the second corridor. Here's the problem nobody could fix in the moment. The system could track 4 separate targets at once, but not 5. The crew fired. There was a 2-second gap of nothing, and then one of the structural drones broke apart at medium range. Another kill. They swung the system around and fired again, but the remaining 4 drones were splitting apart across different bearings now, and every single engagement cycle, acquire, lock, fire, check the result, then slew to the next target, cost precious seconds. The geometry simply stopped cooperating. The radar kept jumping between headings faster than the engagement sequence could actually close on anything. 10 missiles were now gone out of 12. The crew switched to the cannons, 4 kilometers of effective range, which at the drone's speed gave them roughly 90 seconds of shooting window. 1 more drone came apart under cannon fire. 3 structural drones made it through the gun line. The defense system had 2 missiles left, but by now the geometry of the fight was already lost. And on the bridge itself, the train was still crossing. Its cars stretched across the exact span the 3 surviving drones were locked onto. The operators watching this unfold on their screens could see the train still moving at roughly 40 kilometers an hour. Here's the brutal detail nobody could change. A one-way attack drone in its terminal dive cannot retask. There's no calling it off, no redirecting it away from the train. The drones held their course, the train held its speed. For a few unbearable seconds, the 2 paths overlapped completely, warheads descending through the dark toward concrete that still had a live train sitting on top of it. Then the gap opened. 8 seconds, 10 seconds. The last train car cleared the span and kept rolling south into the darkness, completely unaware of how close it had come. The bridge, for one final moment, was empty. The first warhead struck a connection point on the southern support structure, over 100 kilograms of high explosive detonating against concrete and steel. The blast cracked the load-bearing path straight through, and the reinforcement buckled under the strain. The second warhead hit an adjacent section of the deck, and the combined damage from both impacts exceeded everything the remaining supports could hold. One entire section of the bridge, rail, ballast, deck, structural beams, all of it, folded and dropped straight down into the North Crimean Canal. A cloud of dust and pulverized concrete rose up into the night sky. The third drone struck the rail approach itself, severing the track and scattering sleepers across ground where a fully loaded train had been rolling just 12 seconds earlier. 5 of the 8 drones had failed to reach the bridge. 4 were shot down by the defense crew. 1 was knocked off course by the jammer. But 3 heavy warheads had gotten through on a target that had absolutely nowhere to go. A bridge doesn't dodge. 1 span was down. The rail line was cut. The crossing was dead. And then it went quiet. Launch cell Alpha was already gone, the launch site abandoned within minutes of the last drone leaving the ground. Smoke drifted south over the canal. Rubble settled into the water below. Restoring this crossing was going to take heavy machinery, and that machinery had to come in by road. Until it arrived, every ammunition train, every fuel shipment, every troop transfer that depended on this corridor was simply stuck. And somewhere along that canal, in the dark, the resistance cell was still watching. For a few hours, that might have looked like the end of the story. A bridge damaged, a rail line cut, a defense crew standing down after expending most of its ready ammunition in a single engagement. If this had been the entire operation, it would already have been a significant tactical win. A fixed strategic asset taken offline using a fraction of the cost of what it took to build and defend it in the first place. But the people who planned this strike weren't thinking about one night. They were thinking about what Russia would be forced to do next, because a damaged rail line that carries this much military traffic cannot simply be left broken. It has to be fixed and fast, which means someone has to send people and machinery back into exactly the same place that just got hit. Here's the part almost nobody expected. 8 drones for one bridge would have been more than enough for most operations, but this strike was never designed to end with the bridge. It was designed for exactly what happened next, because Russia, predictably, sent in repair crews, and within 45 minutes, 6 more Firepoint FP2 drones from a second team, Launch Cell Bravo, were already in the air, crossing Crimean airspace on a completely different corridor than the one used the night before. This time, the defense saw them coming faster. The Podlet K-1 radar picked up the formation sooner, classified the threat quicker, and handed the tracks off with less delay. The jamming system activated earlier in the flight path, and the ground defense battery, reloaded back up to 12 missiles and repositioned for exactly this scenario, was already tracking the formation before the lead drone even crossed the 30-kilometer mark. The defenders had learned from the first night. It showed. The target this time wasn't the bridge itself. It was a repair machine parked just 5 to 10 meters from the damaged rail line, its boom already extended into the work zone, with a support vehicle sitting 30 to 50 meters behind it. The resistance cell's report on this had been a single line. As long as those repair machines kept working, every ammunition train through this corridor stayed exactly where it was. That one line was enough to greenlight a second strike. 2 pressure drones led the second formation in. The defense battery fired within seconds of first acquiring them. The first missile found its target and the drone came apart. 1 kill. The crew shifted aim a second and a half later, fired again, and the second pressure drone was destroyed before it even reached the inner defense zone. But the engagement itself had already tripped the alarm on the ground below. The crew operating the support vehicle threw it into reverse and started pulling away immediately. The repair machine wasn't so lucky. Its boom was extended, its hydraulic arms locked into the work, and it simply could not disengage and retreat in time. It stayed exactly where it was. 30 seconds later, 4 more drones arrived on a completely new heading, 3 targeting the surviving bridge structure, 1 targeting the rail repair site directly. The defense battery still had 10 missiles left, so ammunition wasn't the issue this time. The problem was geometry again. This new group was approaching from 30 degrees east of the corridor used the night before, and the battery needed a full 8 seconds just to swing its aim onto the new bearing. The crew fired, and the missile needed 3 more seconds to close the distance, 3 seconds in which the remaining drones covered another 130 meters straight toward the bridge. 1 drone disintegrated at medium range. The crew tried to swing back and reacquire the next target, but that drone had already been drifting. The jamming system had been working on its guidance 5 kilometers longer than it had on the previous night's casualty, and the accumulated error had completely overwhelmed its camera. It never found the bridge at all. It struck open ground 200 meters short of the crossing. Its guidance hadn't just drifted this time, it had completely collapsed. 2 drones kept coming. They slipped into the inner defense zone during the exact 8 seconds the crew spent reacquiring the new bearing. The first one struck a surviving connection point between the already collapsed span and the section next to it. That section had already been stressed by the previous night's impacts, and now new cracks tore open, steel ripped free, and the entire section sagged and deformed. No train was ever crossing that section again. The second drone tipped into its final dive, and the operators watching the feed saw the repair site fill their camera frame, the repair machine's cabin sitting dead center in the crosshairs. It struck the same stretch of rail it had originally been sent to fix. The blast swept across the open ground toward the repair machine, which hadn't moved. Its boom was still extended, its hydraulic arms still locked in place. Fragments of concrete and steel tore straight through the cabin and the engine housing. Hydraulic fluid and diesel fuel ignited together, and a column of black smoke climbed into the night sky as the rail beneath it was severed for the second time in 2 nights. The support vehicle, already 60 meters clear by that point, survived. The remaining crew pulled back. The repair effort was over. It hadn't even lasted a full work shift before the second wave of drones turned the entire site into a target. Only 2 of the 6 drones from the second wave actually reached their targets. The defense battery destroyed 3 of the others. The jamming system accounted for a 4th. 67% stopped, genuinely better than the first night. The defense had adapted, learned, and improved in real time. It still wasn't enough. Two more structural warheads landing on an already broken bridge accomplished what a 67% intercept rate could never prevent. One span was already sitting in the canal. Now the adjacent section was cracked and structurally compromised. The rail line had been severed twice in 2 nights. A repair vehicle was burning right next to the very track it had been sent to fix. Somewhere between 70 and 75% of the entire attacked section of the bridge was now either collapsed outright or completely unsafe to use. The bridge as a whole hadn't vanished. Some of it was still standing. But the crossing that had carried Russian military logistics through Crimea for more than 2 years was no longer a functioning crossing. Full stop. Here's what makes this story genuinely uncomfortable if you were designing that defense. It didn't fail because the equipment was weak. Across both nights combined, the defense battery destroyed 7 of 14 incoming drones. The jamming system took down 2 more. That's 9 of 14 stopped. A 64% intercept rate that would look genuinely solid in almost any after-action report. On paper, that's a defense that mostly worked. But a railway bridge does not move. It cannot dodge, retreat, or take cover. It simply absorbs every single warhead that makes it through, no matter how few there are. 3 hits on the first night, plus 2 more on the second, were enough to break what 12 missiles per reload physically could not fully protect. The defense didn't collapse. It wasn't overwhelmed by some obvious failure. It was outrun by simple arithmetic, a finite number of missiles on the first night, a misjudged approach corridor on the second, and both times the margin was lost by exactly the number of drones carrying structural warheads that slipped past the very last line of defense. 14 Firepoint FP2 drones at an estimated $50,000 each comes out to roughly $700,000 in expendable airframes across 2 nights of operations. For that price, Ukraine collapsed an entire bridge span, severed a critical rail line twice, destroyed the one piece of equipment sent in to repair it, and guaranteed that everything Russia needed to move through that corridor, ammunition, fuel, reinforcements, every bit of it, simply stayed exactly where it was. Compare that $700,000 to what actually sits on the other side of that ledger. A modern short-range air defense battery like the one defending this crossing, the missiles it fires, the radar and jamming systems supporting it, the rail infrastructure itself, and everything that infrastructure was supposed to keep moving, ammunition stockpiles, fuel reserves, reinforcements bound for the front, represents a value that isn't even in the same universe as the cost of the drones that took it offline. That gap is the entire logic of this kind of warfare. You don't need to win every engagement. You don't even need to hit every target. You just need the cost of forcing your opponent to defend everything, everywhere, all the time, to be higher than the cost of you occasionally getting through. 9 of 14 drones were stopped, and it still didn't matter because the 3 or 4 that got through were the only ones that ever needed to. The defense system that guarded that crossing is still there. It can reload, it can reposition, it can study exactly what went wrong across these 2 nights and adjust, the same way it visibly adjusted between night 1 and night 2, cutting the number of drones that got through almost in half. But somewhere behind the southern front, right now, a 3rd launch cell is already being loaded. And whatever lessons that defense crew just learned, they're about to be tested again. If stories like this, the kind that actually walk you through how a strike unfolds, minute by minute, system by system, are the reason you watch this channel, make sure you're subscribed to States Report because we track exactly this kind of operational detail that most coverage skips right past. Tell us in the comments, do you think Russia can actually adapt fast enough to hold this corridor, or is this the start of a pattern that keeps repeating? We'll see you in the next one.